One of the things that has gone and made Tesla one of the biggest car innovators in the world, in regards to them leading and dominating the electric car market, is that they're always willing to go and use new technology or push innovation to get the results they want and need. Just take a look at their gigafactories or their very advanced batteries for their cars as proof of that. But now, they're pushing things even further with a machine known as the Giga Press. This device will go and help them make cars even more easily. Allow us to show you Tesla's Giga Press. How does it work? The Giga Press. The Giga Press is the largest die casting machine in the world to date. It can weigh up to 430 tons and have a clamping force of up to 61,000 kN. Additionally, these gigantic die casting machines are as big as a house and capable of casting extremely large components. Tesla happens to be the first company ever to order the Giga Press. Since then, people associated with the die casting industry are eager to see the world's largest die casting machine in action. The name Giga Press was first coined by Riccardo Ferrario, the IDRA Group's general manager. The IDRA Group introduced the Giga Press in late 2018. It has been in their catalog since then. It was only until late 2020 that Tesla had started using a customized OL6100 CS Giga Press for production. However, IDRA had already announced on their website that they had got the first order for a 5,500-ton high-pressure die casting HPDC machine. In 2019, Jerome Guillen, the president of automotive at Tesla, also stated that they were working on a giant machine to make full-size cars in the same way that toy cars are made. Later on in April 2020, Elon Musk mentioned that Tesla had bought 2 huge die-casting machines to manufacture chassis parts for the Tesla Model Y. In August 2020, he made a tweet claiming it to be the biggest casting machine ever made. In January 2021, Elon Musk also announced that the rear chassis of the Tesla Cybertruck will be cast using a Giga Press with over 8,000-ton clamping force. Moreover, Tesla has successfully installed 3 Giga Press in Shanghai and 2 Giga Press at the Fremont factory, and likely has installed more in recent times. What makes it work? The Giga Press is more like a die casting setup than a machine. It is equipped with all sorts of devices and systems required in a die casting process. The components in Tesla's Giga Press include the following. The Giga Press uses 2 sets of ovens for handling the aluminum alloy. One functions as a melting oven powered by natural gas and operates at 850 degrees Celsius temperature. Another oven stores the liquid metal heated by electrical power and operates at 750 to 850 degrees Celsius temperature. It is the core of the whole setup, or the die casting mechanism. It has a similar construction to any regular high-pressure die casting equipment and functions like one, except that it is enormous in size. The Giga Press uses a 4,000-liter tank for creating a vacuum inside the mold. It is made by Fonderix, a Swiss company that first invented the vacuum technology for high-pressure die casting. The quenching tank rapidly decreases the temperature of casting to a desirable limit. It is allowing one to achieve some specific properties for a metal casting. Their mechanical trimming press and laser trim for rapidly cutting of excess metal attached to the casting. There is a recycling system to utilize the scrap metals. The scrap aluminum is shredded and offcuts are utilized for the next casting cycles. Using various inspection devices to check the finished casting, such as CMM X-ray machines. How it works. The working principle of the Giga Press can be divided into the following steps. First of all, we have to melt the aluminum ingots and cutoffs from the previous casting cycle in an oven at 850 degrees Celsius temperature. Then, remove any impurities from the surface and convey the liquid metal into another enclosed oven using heated pipes. That oven maintains about 750 to 850 degrees Celsius temperature. Filling empty space inside the storage oven with nitrogen gas prevents the formation of oxides in the molten aluminum. It also helps to maintain an even temperature. Additionally, operators use argon gas, rotary degasser, and a silicon carbide filter to further remove impurities. Before commencing each cycle, lubricate the die surfaces. A robot sprays about 35 milliliters of soybean oil in a thin layer to enable easier separation of the casting. Then, the vacuum system creates about 50 millibars of vacuum pressure inside the mold cavity. The molten aluminum is transported from the holding oven to the shot chamber of the Gigapress. There, the molten metal is forced inside the cavity using a high-speed plunger. The plunger is also lubricated using 8 milliliters of oil before each shot. Once injected, the casting is left inside until it solidifies. Then, the casting is ejected from the dies at 400 degrees Celsius. The raw casting is then placed in a quenching tank to reduce the temperature from 400 to 50 degrees Celsius rapidly. It helps tackle some defects and increase some material properties. Cool the open die to 185 degrees Celsius and thoroughly clean it with robots to prepare it for the next cycle. The next casting cycle will begin 1 to 2 minutes after the current one finishes. Now, cut each of the raw castings into approximate dimensions using a mechanical trim press. The scrap aluminum is recycled with a scrap metal shredder and added back to the oven. Then, the main casting is checked with an X-ray to examine whether it has any internal defects. The verified casting is further perfected using a laser trim and drilled using a CNC machine for fittings. Finally, check the finished casting's accuracy with a coordinate measuring machine. Advantages. We are hoping for new possibilities with the Gigapress technology taking shape. While still not fully implemented, we can already perceive the potential this technology can offer. Below, we have discussed some advantages of the Gigapress. The Gigapress will greatly improve the production efficiency of large and complex products. The Gigapress will allow manufacturers to cast large single components as opposed to numerous smaller parts. Therefore, it will virtually eliminate the assembly operations involved. Thus, there will be great savings in time, labor, and eventually the cost of production. Casting a larger single piece will allow the manufacturer to produce a lightweight structure and impart additional strength to the casting. Casting a single component would also eliminate the possibility of having alignment issues of parts while assembling. So, it will simply quality control and allow manufacturers to provide high-quality castings. Moreover, it will minimize the need for robots in production and significantly reduce the body shape size. So, there will be savings in land use as well. Current uses. Currently, the major field of application of the Gigapress seems to be automotive castings. Automobiles have complex structures and built using numerous smaller parts. Trimming down the number to a few castings would surprisingly boost production efficiency. Tesla is working on casting the rear body structure of the Model Y using the Gigapress. It will replace 70 pieces of casting into one single piece. They are planning to cast the front chassis component using the Gigapress as well. It definitely changes our view on the current production techniques. Since this is a relatively new technology, it may take some time before seeing more applications of this technology. But given how Elon Musk likes to think, it's not hard to see him go and figure out how to make his cars even faster with them. Disadvantages? The concept of megacasting is surely interesting, but the sustainability of the technique is still questionable to many. Since this is a new technology, there's still a lot of research people need to do on the Gigapress's efficiency, cost, stability, and reliability. The industry has always been skeptical when it comes to embracing a new concept. So, it might take some time for other manufacturers to follow the megacasting trend. Tesla has been successfully producing trial runs on the Model Y rear chassis, although it is certain that it required them numerous iterations to get there. But the design process for megacasting should become easier as manufacturers gain more insight into the technology. Pushing forward. Regardless of what happens next with the Gigapress, it's clear that Tesla is on board with it and Elon Musk wants to use it however he can. Which goes to show you the mindset of the eccentric engineer and billionaire. because he knows the more efficiently he can make these rides, the more he can crank out, and the cheaper he can make it for consumers. So stay on the lookout for things like the Giga Press to also come to Tesla to help speed things along. So, what do you think? What do you think of this look at the Tesla Giga Press? What it does, how it works, and how it might help Tesla with its car making? Do you think that with more innovations like these that Tesla will continue to push the bounds of what they can make? What do you think their next creative idea will be to make better electric cars? Let us know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.